The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Thanks for joining. We're going to give it a few more minutes before we jump in. I'm still seeing a few more folks join, so I'm going to give it another 30 seconds before we take off. All right. Well, hello, everyone. I'm Cara Carmichael with Rocky Mountain Institute, and I'd like to welcome you to today's webinar on connected communities, hosted by the National Renewable Energy Laboratory. So we have a great panel today with folks from Rocky Mountain Institute, the National Renewable Energy Laboratory, and the Department of Energy. So I'll go over a few housekeeping items first. I'll introduce our speakers, and then I'll turn it over to them. So you guys are all placed on mute. We had over 600 folks registering for today's webinar, so we're expecting a big audience. There's going to be a few polling questions throughout the presentation that we'd love your thoughts and feedback on. And there will also be time at the end for Q&A. So please submit your questions either during the presentation or after in the questions box to the right of the screen. Please do keep in mind that we won't be able to answer any questions related to the DOE Connected Communities RFI or the upcoming FOA. The presentation is going to be recorded, and both the slides and the recording will be posted to RMI's website following the event. We'll email out a link to everyone who is registered with that information. So we have a great lineup of speakers today, talking about connected communities and multi-building energy management approaches and case studies. So our first speaker will be Sarah Zaleski from the Department of Energy Building Technologies Office. At BTO, Sarah leads the commercial building integration zero energy efforts, district scale solutions, and a portfolio of data infrastructure projects. Next, you're going to hear from Bill Livingood, who is the Commercial Buildings Group Manager at the National Renewable Energy Lab. Bill oversees development of next generation simulation capabilities and guidance documents, such as the Advanced Energy Design Guides that provide building and U.S. climate zone specific design recommendations. You'll also hear from Seth Coan from Rocky Mountain Institute. Seth is a manager in our buildings program where he works internationally on community scale zero energy districts, analyzing and piloting new models. So thanks again for joining, and without further ado, I'll turn it over to Sarah.
Thanks so much, Cara, and thanks everybody for joining us today. As Cara said, I work for the Building Technologies Office, and at what we call BTO, we invest in energy efficiency and related technologies that make buildings and homes more affordable and comfortable. Our budget is around $285 million a year recently, and our activities include, we do a lot of early stage research and development on various building related technologies. We also work a lot with the integration of those technologies in both homes and commercial buildings. How do you combine those systems? How do you develop the workforce to install and maintain those systems? And how do you set up some of the data infrastructure and other infrastructures to support those improvements? And then we also have a part of our office that looks at building codes and appliance standards. So if we can go to the next slide. Traditionally, our office has really been focused primarily and chiefly on the efficiency of buildings. That still continues, but however, as I know many of you know, the energy landscape in our country is changing in many different ways. So we're seeing an increase of variable renewables come onto the grid, investments at national, state, and local levels with grid modernization. The rapid evolution, in part because of national investment in efficiency and smart building technologies, including sensors and controls, also advances in electric vehicles and various energy storage technologies, and also concurrently to all of these, adoption of carbon reduction goals by, not goals, excuse me, that should read goals, by companies, regions, and utilities. So the question becomes, how does our office and some of our efforts collectively respond to these challenges and opportunities with this changing energy landscape? So if we go to the next slide, part of that solution is the Grid Interactive Efficient Building Initiative out of the Building Technologies Office. And this is really looking at a more dynamic relationship that buildings have with the grid, not just being consumers of the grid, but also potentially prosumers, changing when shifting their loads and flexing their loads to use energy at times that are less congested on the grid to help improve overall grid reliability and some building occupants. So if we go to the next slide, you'll see a little bit more about, sorry, we have to click through a little bit of this animation if you'll bear with me. But so how do buildings interact with their building, and how does the building interact with the grid? So looking at more interoperable integrated systems that are continually optimized for the operation for maximum efficiency and comfort for their occupants. And that also can respond to grid signals, so can use less energy when and electricity when needed, and also potentially store and send back energy when the grid needs it. So just a much more dynamic relationship with the grid. So there's a number of benefits that come with this that we can discuss on the next slide. So you'll see that opening up and enabling more flexible loads in buildings can certainly improve energy affordability, reliability of the grid, reduce grid congestion, allow for enhanced services and more options for consumers and occupants. Certainly there can be environmental benefits if you're shifting to lower carbon intensive times of use, and also enable customer choice. So we're really thrilled about many of the benefits that will accrue to many different parties as a result of some of this work. So if we go to the next slide, when you take what we call Grid Interactive Efficient Buildings, or GEBs for short, and you combine them with multiple buildings, you can see even greater results and benefits. So if we can click through some of these, bear with me on this animation. Certainly, we can see economies of scale when you're looking at the multi-building scale. You can see opportunities to leverage diversity of load among buildings. So, when buildings are using buildings are using higher demand or calling for higher demand at different times, they can kind of, working in aggregate, maybe reduce some of those peaks to the greater grid. Able to collectively afford and share some infrastructure that might not be feasible at an individual basis, such as storage and renewables. Obviously achieve greater impact through scale, and I believe there's a few additional ones here. Hopefully facilitate incorporations of additional distributed energy resources, allow for innovative business models, and really achieve more in an aggregate than the sum of their individual parts. And I know Bill and Seth will be talking a bit more about this later on in the presentation. We go to the next slide. Many of you may be aware that DOE continues to invest in this area and has the intention to invest an additional $42 million into what we're calling connected communities. We're hoping that this funding would enable GEB communities to share research results and lessons learned across different areas of the country, and to really scale some of these solutions to ultimately increase grid reliability, resilience, and security. So the purpose of this investment would be to demonstrate and evaluate the capacity of buildings as grid assets by flexing their loads in both new developments and existing communities. We're hoping to do this across a diversity of climates, geography, and building types, and as well as grid and regulatory structures, so we can really understand what works in a variety of different settings. And we'll be taking a coordinated research approach, so really looking at pulling together the lessons learned, synthesizing those, and sharing them with the broader community, because I know there's still a somewhat nascent field that we have a lot to learn in. So if we go to the next slide, So one thing I wanted to address quickly is this term connected communities. It is not at this time a proper noun, and it's not a branded term. And so at this point, it might be used, I think, in similar ways, but maybe the definitions aren't always exactly the same in the NREL paper that we're going to be talking about today and learning more, where they're defining connected communities as collections of buildings and distributed energy resources that incorporated integrated energy management strategies at multi-building scale. Not dissimilar from that, but slightly different wording. The DOE RFI that was released this spring referred to connected communities as a group of, again, GABs with diverse, flexible, and use equipment and other DERs that collectively work to maximize building, community, and grid efficiency. So in case you're wondering, there are a couple different ways to define or to think about really what I think are these collections of GABs for grid security. So communities could take many forms. Some people think of communities as a residential neighborhood, which certainly I think could fit this definition, but it could also be a mixed-use development, a downtown commercial district, a university, a corporate campus. Could also be a geographically dispersed building portfolio. So perhaps through utility territory or something else where buildings are not contiguous, but can still be optimized across them. And this, like I said, I mentioned earlier, could be both new construction and development or existing building retrofits in existing communities. So I just have a couple other slides here. The next slide, if we could go to that. So quickly, ways to engage. So I mentioned we did release a request for information that was open March 27th through May 12th. We had an overwhelming amount of feedback, which is exactly what we had hoped for. So that's great news. I know there's lots of interest in this topic out there. We have reviewed all of that feedback and are hoping to release a FOA later this year. So we do recognize that the types of projects that we're interested in are large and oftentimes complex, and really hoping that we have those projects are represented by an integrated group of stakeholders for the relevant decision makers. And you'll see a list of some of the types of folks we're talking about here. So in order to do this, we actually have developed a teaming list too. So if you are one of those entities and you'd like to be one of these projects and are interested in other folks that might be good to team with, please feel free to email us here, and we will also keep that teaming list updated on DOE's EERE's Energy Exchange, where we have posted information about RFIs and funding opportunities announcements. So no funding opportunity is posted at this point, but if you are interested in either reviewing the RFI or receiving more information, please check out EERE Exchange for more information. So thank you again for allowing me the time to talk this afternoon, and I'm going to turn it over to Seth to get a little bit more into the findings of the paper.
Great, thanks, Sarah. We're delighted by the turnout today. Could it be that we're all craving connectedness and community these days? In all seriousness, I'm glad to be presenting today on our Connected Communities work in partnership with DOE and NREL. Today's webinar is the culmination of what's been almost a year-long process of exploring and understanding the landscape of connected communities from an energy management perspective. Next slide, please. We've recently published a white paper entitled Connected Communities, a Multi-Building Energy Management Approach, which I encourage you to download and read. Today, we're going to summarize some of our key findings and insights from this work. However, you'll find quite a bit more depth and detail on the subject in the white paper. Next slide, please. When we started this research, the key questions we wanted to answer were, what are the main characteristics or common elements of connected communities? What is the value proposition of connected communities? That is to say, what are the advantages of a multi-building energy management approach versus a building-by-building energy management approach? Who are the key stakeholders driving these projects, and what are some of the business models that shape these projects? And through this process of research and inquiry, we wanted to develop an inventory of projects that exemplify some of the key characteristics of connected communities. We set out to answer these questions through a literature search by conducting a nationwide survey that was promulgated through our networks and partnership channels, and by conducting in-depth interviews with stakeholders that have been deeply involved in exemplary connected community projects. Next slide, please. And next slide, you can advance. Through our research, we uncovered some common themes associated with connected communities. What we're referring to here is key characteristics. It's important to recognize that the characteristics listed here, grid interactive efficient buildings, multiple technologies deployed, multi-building optimization through intelligent controls, and shared systems are not by any means the only characteristics or even necessarily the defining characteristics of connected communities, but rather these characteristics represent some common trends that we've uncovered. As this is a DOE initiative, there is of course an emphasis on the nation's energy interests and the needs as well. In addition, I want to point out that varying combinations and configurations of these characteristics were found in our research of projects. From this observation of many projects with varying degrees to which these characteristics are integrated comes our hypothesis, which stands to reason that the greater the extent to which a connected community incorporates the full spectrum of capabilities, the greater the ability to unlock the potential value. The next slide, please. The first characteristic, which I would posit as one of the most critical, is that connected communities employ grid interactive efficient building or GEB strategies. GEB is a term that you've heard Sarah mention and the DOE uses, as well as the building industry uses to describe, and I'm quoting the DOE definition, an energy efficient building that uses smart technologies and on-site distributed energy resources to provide demand flexibility while co-optimizing for energy cost, grid services, and occupant needs and preferences in a continuous and integrated way. Essentially, connected communities employ load flexibility strategies at the multi-building scale through a central controls platform capable of two-way communication with the grid, building loads, and other distributed energy resource technologies. Next slide, please. It's not uncommon for connected communities to deploy multiple technologies and strategies, including building load flexibility, renewable energy generation, and energy storage, but it's also not necessarily imperative. We've seen project examples that incorporate a range of technologies, and we've seen examples of a single technology that increases load flexibility and that is deployed across multiple buildings. Connected communities may be comprised of contiguous buildings, perhaps with physically connected systems via microgrid or some shared thermal system, or a connected community may be a group of contiguous or even non-contiguous buildings that are virtually connected. Ultimately, the priorities and objectives of project stakeholders will dictate the technologies and the strategies that are deployed in a project. However, as more strategies are deployed in tandem with one another, stakeholders may realize more direct financial value, as well as drive greater value with indirect benefits. And we'll get into the value propositions a bit later in the presentation. But in other words, a key takeaway from this inquiry, which I touched on previously, which I should say remains a strong hypothesis that warrants more real-world data collection and verification, is that technologies and strategies build on one another synergistically and create a cumulative effect by unlocking additional value streams. Next slide, please.
Thanks, Seth. Another important characteristic that we found through the sample inventory process is multi-building optimization. As distinguished from managing energy resources at a single building level, some connected communities not only manage energy across multiple buildings, but employ strategies to optimize energy use and dispatch of distributed energy resources across multiple buildings. By coordinating the energy management across the multiple buildings, the potential to maximize the benefit across multiple value streams exists beyond that of just a building by building approach. Next slide. There are many other examples, solutions, and tools that help perform multi-building optimization for both planning and operations. And I do not have time to go through all of those, but I wanted to provide one example of a tool that through comprehensive parametric analysis and optimization routines helps uncover near optimal strategies. This DOE tool, developed by multiple national labs and universities, is called the UrbanOpt Software Development Kit. It aims to address the technical underpinning that then allows the private sector software tools developers to quickly create new advanced capabilities for the many connected community stakeholders. A quick note is that UrbanOpt is even more powerful when paired with other grid simulation platforms. As you can see from this figure, NREL, other national labs, and universities are developing the kernel, but we have pilots underway with private sector entities that are addressing the other layers in this figure, all with the goal of optimal or near optimal designs and operations. Next slide, please. Connected communities have yet another important characteristic, and that is that they can benefit from shared systems. As you can see from this graphic, through district thermal systems, or sometimes called thermal microgrids, waste heat can be shared by nearby facilities to satisfy neighboring building needs, which could then greatly reduce overall energy consumption. Next slide. Yet another example of possible benefits of shared systems is depicted in this figure. In this case, the connected community could take advantage of load diversity that happens across multiple building types, and if a thoughtful approach is used, one could reduce capacity requirements and therefore capital costs. Next slide. Or sorry, if you could bring up the poll question at this time. If we could transition to the poll question, there we go. So through our sample inventory, we found 4 characteristics, and we're sure that there are other characteristics, but we now would like to make this webinar more interactive, and we'd like to hear from you. What do you believe is the most significant characteristic of the 4? So if you could use that quick poll and highlight your belief in the most significant, we'd love to hear back from you.
Okay, I think the votes are starting to slow. Great, so about 40% of you guys responded saying that grid interactive efficient buildings are the most significant characteristic, followed by 35% saying that multi-building optimization was the second most important characteristic. So I think that aligns with our research and the findings. Thank you.
Well, thank you, everyone, for taking a moment to give us your insights, share your insights. I think with that, we'll transition into the next slide.
Great, thank you. And we can advance one more, please. Excellent. The key question asked in assessing the merits or the value of the connected community approach is, what is the additional value of employing energy strategies that involve multiple buildings? In other words, what can a well-designed multi-building connected community do better to unlock value propositions compared to a building-by-building approach? The list of benefits shown here are by no means exhaustive, but indicate that there are a host of direct financial benefits as well as indirect benefits that may be slightly more difficult to quantify. In the following slides, as we discuss some of the benefits, what we're really focused on is that key question of the additional value of the multi-building connected approach. Next slide. From the customer or building owner's perspective, there are a number of potential benefits. For example, with centrally installed systems such as renewable energy or energy storage, first cost savings are possible through bulk purchasing, streamlined installation, and reduced total capacity requirements. There may be maintenance savings associated with shared systems as a result of reduced operator costs and reduced maintenance and repair costs of centralized systems. Building owners may enjoy energy bill savings as well. For example, with energy efficiency retrofits that lead to bill savings, economies of scale may be leveraged through multi-building energy upgrades. There are opportunities associated with aggregating loads. By aggregating loads across multiple buildings, customers may be able to switch to a more favorable rate structure, resulting in energy bill savings. In the case of contiguous buildings, a master meter across multiple buildings may reduce demand charges because the community peak is typically lower than the sum of individual peaks. Aggregating load may also enable greater participation in a wider variety of demand response programs. Furthermore, taking advantage of load diversity across multiple buildings can unlock significant value. For example, with greater load diversity, a single energy asset can reduce peak demand of multiple buildings that have non-coincident peaks, thereby saving the customer on demand charges and getting more value per unit of installed capacity. Taking advantage of load diversity and shared assets can increase resilience of a community. That's the ability to ride out a power outage. Since a larger portion of the building loads within a community may be supported in an islanded state. And leveraging load diversity across multiple buildings can lead to higher percent usage of installed on-site generation. We recognize that we likely have not captured all of the value streams, but in addition to the ones I've just mentioned, there are a host of other direct and indirect customer benefits that we identified and discussed in greater detail in the paper. Next slide, please.
Thanks, Seth. So for connected communities, they better enable energy efficiency and demand flexibility that not only benefits the building owners and operators, but the utility as well. And we've listed a sample here of some of those benefits. So with that demand flexibility, energy efficiency, we can reduce capacity requirements. We can also streamline energy efficiency program delivery through the community-wide approach as opposed to a building-by-building approach. The community-wide approach lowers transaction costs, if you will. Increased reliability also results from the connected communities approach, as well as GHG reductions as well. Next slide.
I'll jump in here. The intent of this graphic is to show visually what we've described in the previous two slides. That is that the connected community approach can lead to increased benefits. This graphic shows the potential customer side benefits. On the left side, we've identified those benefits that may result from deploying GEB strategies or distributed energy resources on a building by building basis, whereas the right side indicates the value streams with the multi-building connected community approach. You'll notice on the right side, there are additional value streams that do not appear on the left. In addition, with the same number of buildings on both sides, if you were to aggregate the value across the buildings for the building by building approach versus the multi-building approach, we believe you'd see a higher value potential with the connected community approach. That's what we described, some of those benefits that increase the value across the customer side as well as the utility side. Next slide, please. So for this one, it's another polling question. So we invite you to provide your input here on what do you perceive to be the most significant benefit of the connected community approach for direct benefits. Of course, as mentioned, there may be others, but for these particular ones that we've identified, we'd like to hear which ones you think are most significant. We'll give it a second. Cara, are you seeing the results?
Yep, so I think the result incoming responses have slowed. This one is a little bit more even. Yep, we're seeing the highest the most significant benefit being energy conservation, closely followed by CapEx and OpEx savings, followed by demand response and ancillary services. And I would venture that those three are likely closely related to one another.
Great, that's helpful. Thank you. So we're going to transition to the market and technical challenges. And if we could advance one more slide, please. There are relatively few projects that currently leverage the full extent of the opportunity. We believe in part this is because the connected community approach is relatively novel and market conditions as well as regulatory regimes are not fully aligned to support high levels of connectedness in retrofit or new construction projects. And there are specific market and technical challenges that remain as potential barriers to scaling the connected community approach. For example, in many cases, utility rates and incentives are not yet dynamic enough to fully reflect the real-time needs and constraints on the electric grid, thereby truncating the economic value that connected communities may be able to offer. Regulations in the energy sector, such as the ability for demand-side resources to participate in wholesale energy markets or be properly compensated for their services in vertically integrated markets, varies by region and or state. In some cases, regulations are more conducive to connected communities, while in other states, regulations are hindering the adoption of connected community practices. In addition, variation across the U.S. regulatory landscape governing interconnection of distributed generation and storage and the ability for third parties to provide energy services presents challenges to some businesses. Working across multiple buildings with, in some cases, potentially multiple owners poses its own set of challenges associated with coordination and alignment, as well as allocating costs and benefits across stakeholders. We mentioned some of the indirect benefits, what may be termed as non-energy benefits, including resilience, greenhouse gas reductions, even community development benefits. Often a lack of standardized approaches to identify and or value the non-energy benefits of the investments may be a hindrance to performing meaningful cost-benefit analyses. Costly infrastructure and logistical planning associated with shared systems can be prohibitive for some projects. And a lack of familiarity with the concepts and practices related to connected communities may hinder the rate of adoption. Practices associated with connected communities could entail changes to the way building systems are designed, managed, and operated. And until awareness of these concepts and approaches become more commonplace, stakeholders may be reluctant to adopt changes that are not fully vetted or well understood by their personnel. We're hoping that today's presentation is a step in the right direction towards increasing awareness of the opportunity. Next slide, please.
Great. There are many technical challenges to overcome in order to achieve the full potential of connected communities. I'll go through 4 of these at this time. So first off, lack of interoperability does result in higher soft costs. Keeping an optimistic view of it, though, through a public-private partnership, Department of Energy and NIST are making investments to make improvements on that front. In addition, multi-objective analysis and design, such as planning for a connected community project, takes advantage of a full value stack, but it's a complex endeavor. Again, from an optimistic viewpoint, Department of Energy is making investments on this front to make it more convenient. And an example of that was indicated already. That's the UrbanOpts project, and contributing an open source solution that the private sector can take and run with. In addition, with greater connectedness, there are cybersecurity risks. throughout the government, there are investments being made to improve cybersecurity to hope in addressing those risks. With district thermal and central thermal storage systems, there can be technical challenges associated with piping installation in some subsurface conditions, as well as efficiency loss with transporting that thermal energy over longer distances. Although so-called ambient temperature loop systems or fifth generation district heating and cooling networks, those heat loss challenges can be overcome. Next slide.
Great, we're going to transition into presenting some case studies. And based on a nationwide search, we have constructed an inventory of close to 50 connected communities around the country that are in various phases of implementation. We have tried to make this as representative a list of the types of projects out there, but certainly this is not an exhaustive list, and we apologize if we missed a project that you are aware of or that you might have been involved with. We identified projects of most use types you can imagine, from residential, commercial, mixed use, campus projects, as well as portfolio projects of non-contiguous buildings. In line with the idea that there is a spectrum of solutions, we've categorized projects as incorporating most, if not all, of the characteristics that we have identified versus those projects that demonstrate some of the characteristics and thus capture a smaller portion of the potential value. You'll find a short description of each project in the white paper. And next slide, please. Also in the white paper, we went into a little bit more depth on some cases, and this is one of them. There are many excellent projects out there, and in the white paper and here in this presentation, we've selected just a few indicative examples to highlight the range of possibilities. The Lancaster Virtual Power Plant project is one of them that integrates a number of connected community strategies. It is a network-based aggregation of distributed energy resources that has a regional footprint spanning across the service territory of Lancaster Choice Energy, a community choice aggregator in Southern California. The Lancaster VPP is targeting to aggregate 10 megawatts of solar, 5 megawatts of energy storage, and 10 megawatts of flexible load capacity across a diverse set of developments, including 3 school microgrids with solar and storage, as well as EV charging resources, 2 residential microgrids, one with 78 homes and the other with 164 homes, both plan to have solar, battery, and EV charging resources, as well as additional schools and municipal facilities. Olivine, a third-party integrator and demand response provider, will operate the VPP on behalf of Lancaster Choice Energy. Through a sophisticated controls platform, the VPP will optimize which resource is dispatched when in order to maximize value, including participation directly in wholesale energy markets. After customer-side value streams are maximized, the VPP's reserve capacity will be used primarily to avoid high wholesale procurement costs and to maintain enough demand response capacity to count toward Lancaster Choice Energy's resource adequacy. Next slide, please. The Seasons at Ontario project is provided here as a contrasting example to the Lancaster VPP. This is a multifamily residential project with 8 units of low-income senior community housing. The project encompasses 5 contiguous buildings. This project is driven by the building owner, Link Housing Corporation, an organization focused on creating affordable housing. Link partnered with the Electric Power Research Institute on this retrofit project. The primary motivations for the retrofit project were to demonstrate how a near zero energy retrofit that incorporates distributed energy resources, including solar, energy efficiency, and demand response, can reduce tenant energy bills, as well as reduce the owner's operating expenses. The project incorporates a controls platform to perform integrated demand-side management, taking price signals, including time of use, day-ahead pricing, and demand response signals to control the smart thermostats in the units. The controls are designed to streamline the monitoring and optimization of the systems for the end user. Just imagine senior citizens or any end user or building owner for that matter, trying to contend with real-time grid signals and building data to make operational decisions on the fly. This is a great example of the need for these systems to manage the complexity of the data inputs automatically in order to benefit the customer and the end user. The system aggregates the resources and controls the community of devices to provide grid services and in turn customer savings. Next slide, please.
We're very excited about the Connected Communities approach, and we're glad that you spent time with us today to engage on the topic. I'd like to close with some conclusions and then transition into a Q&A session. So one, it's a tremendous opportunity. I think we can take note that there's over 600 registrants for today's webinar, so that is an indication of how large of an opportunity it truly is. It's really an untapped potential across the country. We have many enabling technologies being developed currently that will allow us to seize that potential. It's not only for new buildings, new construction, but also highly relevant to existing buildings. It's very relevant for multiple building types. And it's really part of the solution for CapEx, OpEx savings, GHG reductions, and increasing resilience. At this time, I'm turning it over to Cara Carmichael for a Q&A session. Next slide. Oh, and maybe one quick shout out, if you will. This was not accomplished by just the speakers today. We had many that contributed to this overall effort, and we're very appreciative for all their contributions.
Thanks, Bill and Seth and Sarah. Great presentation. Really appreciated it, and I think it's really inspiring to see that these high-level aspirations, they're make it a little bit more tangible, and to see that it's being done today in a lot of different ways. So that's great. And thanks to everyone for attending. We have about just over 15 minutes for some Q&A. We've been getting some great questions as we go along, so please feel free to add yours in there. And just a reminder, we're going to send out a link to the recording from this presentation on RMI's website in the week following, and we'll send out a note to all registrants on where you can find that. So I think the first question, and Sarah, maybe I can direct this at you, and Seth and Bill, feel free to jump in, but COVID showed us that it is much more important to understand the effects of human behavior and usage trends in order to optimize operations. How do you see the future of smart buildings after COVID? You're on mute still, Sarah. Sarah, you're on mute.
Thank you. I was just saying, thanks for starting with an easy one for me. As a walker, I have a question. So I don't know, we're all kind of figuring it out. I mean, I think, we've received a lot of questions and have been thinking through answers, as I know a lot of other organizations are, about, dynamically interacting with your building in times when it's not occupied. Both, how do we restart buildings now? How do you manage them remotely? What technologies are going to be most valuable to install, in the coming years for the chance of, shifting operations or occupancy and remote operations. So I don't have the answer to that, but I do think a key is going to just be flexibility in many different dimensions. I think that expands to how we use buildings. What are we doing with many of the office buildings that are sitting vacant, and also housing shortages? And so is there a future where some of what were traditionally commercial buildings turn into residential buildings? So everything from how we use our buildings to how we operate them to when we're using energy. And so I think there's a lot of different dimensions of flexibility we'll be talking about in addition to when you're using energy. So my hope is that, this is a step in the right direction. We're going to be learning a lot over the next few years with some of these projects, hopefully. And I know we're currently doing some work with Georgia Tech that Seth and Bill are also very involved with. And it's been a nice opportunity this summer to kind of think through how do you play with some of those controls in an environment where you're not as occupied traditionally. So it gives us a little bit more of a natural experiment, and also grounds to do some experimenting that might otherwise be difficult to do in a fully occupied building. So I think we're trying to take advantage of this otherwise really unfortunate event to see what we can learn. So a lot to still learn, but certainly I'm glad that people are thinking along those dimensions and asking those questions.
Thanks, Sarah. This is a question to maybe either Seth or Bill. Must connected communities be utility grid connected, or can they be operated autonomously? Is there a business case for non-grid connected communities? Seth, do you want
to comment on that one?
Go ahead, Bill. Great.
Yeah, I believe that connected communities provides value to grid-connected communities, as well as islanded or grid-independent communities, as well as communities that could conveniently transition from one of those modes to the other. Right. Actually, the many benefits that we talked about today in terms of let's say one example in lowering capacity requirements, CapEx requirements, actually becomes more pronounced in a grid-independent state, or in a microgrid type state, where you don't have as much of a buffer to take advantage of, where the intelligence, if you will, really allows you to look at creative ways to lower those capacity requirements. And so in that case, the connectedness is the buildings within that contiguous area that of that community that is operating in that grid independent state. So great question, and I think values extend in the three different paths there.
Great.
Agreed. Yeah, I think Bill's right on there. One project example that comes to my mind that kind of highlights that principle of there's value with the grid connected community as well as the sort of off-grid community is this project called Isle of Hot, which we briefly touch on. It's a great example. They're working through solutions right now. It's an island off of the coast of Maine, which has a cable, as their grid connection through, underwater, and it often gets compromised. And so they're looking at the opportunities around this, community connected approach to balance loads within the community to provide those services that they need when they're off grid. And they're going even further to look at how do they share the costs and the benefits, even using blockchain, potentially blockchain technology to allocate those benefits. So some innovation is really possible in that space.
Thanks. This question I'll direct to Bill. What will utility reactions be to connected communities leveraging diversity behind a master meter? The utility was no doubt taking advantage of the diversity in their transmission distribution network, but was also gaining income. Thoughts on utility perspective?
Yeah, I think with this very significant change in a paradigm, we do have to explore different business models where these new value streams somehow provide a broader value to all stakeholders. So I guess in many ways we need to develop sound technical solutions, but in conjunction with the creative business solutions, if you will, such that we achieve a scenario where the tide, a rising tide, lifts all boats in the harbor, if you will, and I believe that that's achievable. We're going to have to change our approaches very significantly on that front in order to make that a reality.
Thanks, Bill. This is a question to Seth. How to transfer the monetary benefits from connected communities, such as reduced electric peak demand and improved resilience to the grid, to building owners and tenants?
It's a good question. Well, so I gave some examples of that where there are systems in place that can manage the end user's consumption in real time based on grid signals, and those benefits go directly to the consumer based on peak demand charges. I think, and what was the other example? Demand charges and time of use charges. So that's happening based on these systems that may automatically make decisions for the end user, and the end user has the opportunity to opt in, and or has the control to override those systems. I also should note that there's those systems are providing grid services. That's why there's a benefit to the utility and to the customer both, and so the customer can benefit through reduced their reduced energy bill costs, as well as we hope to see, as those benefits transfer to the utility in terms of reduced capacity requirements, that those benefits sort of trickle down to the end user in the form of lower energy costs as well.
Thanks, Seth. I think one question that kind of builds on this, and maybe I'll direct it at Sarah, is what is the economic prospect of the connected communities? Will the cost be higher than conventional practice for individual buildings, and how can that increase in cost be paid for?
Yeah, that's a great question, and not one that's unfamiliar in the traditional energy efficiency discussion, right? And looking at life cycle costs and what is, if anything, an upfront premium, how is that amortized over time, and how does that made up for in both kind of operation and oftentimes maintenance costs as well. So I think you need to really look at the whole picture. We'll see. It's if you add an extra widget, sometimes that comes with an extra cost. I do think we're learning more and more about how you use more sophisticated, more mature integrated design to look at some of the trade-offs between adding some of these and maybe downsizing mechanical equipment if you're going to be reducing, that peak load. So I do think there are some opportunities for upfront capital savings, and certainly when you're looking at as was mentioned throughout the presentation, at aggregates of multiple buildings, I think you can have economies of scale, not just in potentially equipment and buying in bulk, but also potentially in professional services to design and install those, as well as potentially pooling resources for, let's say, storage or other distributed energy resources. So I think that's, again, a big part of what we're trying to figure out, right, is it's not just what the technologies are. We have these technologies on the shelf today, but how do we pull it off? Like, how do we bring stakeholders together to pay for the upfront costs? And how do we set up systems so that those stakeholders can recoup those costs over time, so it really does become an economic benefit to them? And so I really believe that that's possible. I think we've seen some examples of that. And then obviously, hoping to see costs reduced for your energy costs over time. But yeah, so some of the things we're trying to figure out. But yes, it is possible.
Thanks, Sarah. I think we have time for one or two more, and I'll direct this one at Seth. There have been a few questions around carbon impacts. And what are the carbon impacts of connected communities? Is there research going on to try and quantify the potential GHG reduction if connected communities are adopted at various levels? 25% of a country, 50, 75%?
Sure, great question. Certainly, we see there's potential there with connected communities to impact greenhouse gas emissions. It can go either way, but a sophisticated system can optimize for greenhouse gas emissions and what we call marginal emissions in carbon intensity on the grid. So if that is an input into the controls, the controls platform can shift load away from times of consumption when there's high grid carbon intensity. And what was the second part of the question? I'm not sure I fully understood that.
Research around penetration levels at like country scale adoptions. Like if it were to be deployed at large scale, is there exponential impact potential?
So certainly, I would say yes. I think it's also at regional scale. I would say yes. Sarah, do you have any?
Absolutely, yes, certainly. Yeah.
Thanks. Great. And last question, I'll direct to Bill. This is a cybersecurity related question. What increased chances of cascading failure do interconnectivity and new paths for attack via cybersecurity methods? How will we ensure that resilience is truly increased?
Sure, excellent question. We're definitely, with the greater connectedness, we're definitely introducing greater risks. However, if we just approach a business as usual approach, not recognizing the many challenges that are happening to the grid already, for example, a greater extent of variable renewable energy on the grid, we're going to have instabilities potentially introduced, as well as just different forms of use that are going to potentially offer up different instabilities, different more extreme weather events, also making us have less resilient systems, if you will. So we're between a rock and a hard place in many ways, that if we do nothing, we're going to be more vulnerable. And then if we do make advancements in greater connectedness, we're also introducing risks. So I think the bottom line is it's better to be proactive. It's better to be very thoughtful. It's better to do your homework for all of us in this research circle, if you will, to provide very robust solutions to ensure that we minimize that risk as much as possible. So I do think it's manageable, but we're going to have to really roll up our sleeves. We're going to have to go to work and come up, dedicate a lot of hard work to it, a lot of creativity to come up with robust systems to avoid those challenges that the attendee put forth in the form of a question. But doing nothing also causes risk as well. So I think that's important to recognize.
Yep, great. Well, thank you, Bill. Thank you again to all our presenters. Excellent content, excellent presentation. And thank you for all the attendees for joining us today. Sorry I didn't get through all of the questions, but feel free to reach out to us for any follow-ups needed. And thank you again to everyone. Have a great day.
Bye. Thanks.